Hello everyone. In the last lecture, we had talked about subsets and we had seen two relations. So here are some questions based on those two relations. So the first one is there's a survey of 100 people and it is found that there are 28 people who read magazine A, 30 read magazine B, 42 read magazine C, 8 read A and B, 10 read A and C, 5 read B and C. There are 3 who read all the 3. In the first part, we are supposed to find number of people who read none of the 3 magazines. In the second one, how many people are there who read magazine C only? So on the Venn diagram, this first part, how many people read magazine? None of the 3 magazines would be this portion for us. So the first part is none of the 3 magazines are being read is this portion. So that's the first thing we have. In the second one, I'm supposed to find number of people who read C only. So we'll talk about the C only in a while. First, what I'll try to do is I'll write the information that is given to me in this Venn diagram first. There's a survey of 100 people. So I start from the last one. There are 3 people who read all the 3 magazines. All the 3 means common portion of A, B, and C, which is this one. Number of people who are reading all the 3 magazines is the portion represented by this one, this region. So there are 3 people who read all the 3 magazines. Then let's talk about this region. This region is A intersection B. And we have been given there are 8 people who read A and B. So since 3 people I have already accounted for and they are reading A, B, and C, what remains is 5 people who read A and B only, not the C. So 5 plus 3 becomes 8, which is what A intersection B is. 3 represents number of people who read all the 3 magazines. 5 represents number of people who read A and B, but not the C. Now we'll deal with the second portion here, this one, which is the portion of intersection of A and C. We have been given A and C has 10 people there. So out of those 10, 3 have been accounted for. What remains is 7. Same thing we'll do for B intersection C. B intersection C has 5 elements in it, of which we have already accounted for 3. So what remains is 2. Now I'll try to find these numbers here, here, and here. The whole of A, 28 people read the magazine A. So So if I want to find this portion only, nothing else, that would be from the 28, I'll subtract 5, 3, and 7. That would be 15 here. So 28 minus 15 would give me a 13. The second one, this region, I'll try to find this quantity now. Number of people who read magazine B is 30, of which 5, 3, and 2 I have already taken into account. So what I get is a 20. Third one, this portion C only. C is being read by 42 people, of which 7, 3, and 2 I've already taken into account. What remains is 12, and that's what gives 42 minus 12 gives me 30. So this is what I have. So this whole of the region is the union of A union B union C. So let's talk about the first part now. I'm supposed to find this external shaded region. So to get this external shaded region, number of people who read none of the 3 magazines. To get this region, to get the number of people in this set, I'll just subtract number of elements in the universal set. So number of elements in the universal set minus number of elements in M union P union C. Universal set has 100 people in it. So From 100, I'll just subtract the quantity, which is M union P union C. Now to get the M union P union C, either I can use the formula that I gave the last time, or I can just use these numbers. I'm just using these numbers. M union P union C would be 13 plus 5 plus 3 plus 7 plus 20 plus 2 plus 30. And that gives me 100 minus an 80 here, which when you subtract, you get 20. So that's what I have for the number of people who read none of the three magazines. In the second part, I have been asked how many people read magazine C only. So the C only portion is this one. This region is the number of people who read magazine C only. And we have already found the answer for it. The answer is 30. Number of people who read the magazine C only is 30. So this one is done then. Let's move on to the next one. In a survey of 220 students, it is found that 125 people, at least 125 and at most 130, studied mathematics, at least 85 and at most 95 studied physics, at least 75 and at most 90 studied chemistry, 30 study both P and C, 50 study both C and M, 40 study both M and P, 10 study none of the three. If M and N are denoting least and maximum possible value of students, number of students who studied all the three, then what can you say about the value of M plus N? So small m denotes the least possible value of number of students who study all the three, and n is the opposite one, the maximum possible value. So let's write the information that is given to us. Number of people who study maths alone is bound between 125 is greater than equal to 125 is less than equal to 130. Number of people who study physics only is bound between 85 and 95. Number of people who study chemistry only is bound between 75 and 90. There are 30 people who study physics and chemistry. There are 30 people who study physics and chemistry, 50 people who study maths and chemistry, 40 who study maths and physics, and none of the three subjects, 10 people are there. The number of people who study none of the three subjects, that would be 10 here. And we are supposed to talk about this common intersection portion, which I have marked as capital X. So let me find the union of the three sets first, because that way I can relate the union with the small intersection. So number of elements in the union of M, P, and C is equal to number of elements in the universal set minus number of people who study none of the three subjects. The universal set has 220 elements in it, of which we are subtracting 10. So the union has 210 elements in it. Now we already know one relation, which is number of elements in M union P union C is equal to number of elements in M plus number of elements in P plus number of elements in C minus number of elements in M intersection P, number of elements in P intersection C, number of elements in M intersection C plus number of intersection elements in all three, and that is 210. We are supposed to find the minimum possible and maximum possible value of M intersection P intersection C, number of elements in them. So number of elements in M intersection P intersection C, I'll shift everything to the right side now. So the quantities related to these sets, I know them all. So 210 is there. So 210 plus M intersection P, P intersection C, M intersection C, that would be 30, 50, and 40. And the other three are NM plus NP plus NC. This is gonna be same as 210 plus 120, that would be 330 minus number of elements in NM plus NP plus NC. Now, if I want the least and the maximum possible value of this set, number of elements in this set, I'll try to use the relation information given to me about these three sets. If this is maximum, these have to be minimum. If this is minimum, these have to be maximum. So the maximum possible value would be, okay, so let's talk about the minimum, small m. Small m comes when I take the maximum of these three. The maximum possible values these three sets can take are 130, 95, and 90. So it would be 330 minus 130 plus 95 plus 90, and that would be equal to 330 minus 315. That would be equal to 15 here. So the least possible value that number of elements in M intersection P intersection C can take is 15. So small m we have found, and now we need to talk about the capital M also. Now let's see what happens when I take the minimum possible values here. If I take the minimum of these three, the quantity that I get is 330 minus number of elements in M. What I'm trying to do is figure out what the maximum possible value of intersection of M, P, and C can be. So NM plus NP plus NC is what I have. That would be 330 minus 125 plus 85 plus 75, which gives me 330 minus 210 plus 75 is 285, which is giving me 45. So I would be inclined to think now that number of elements in M intersection P intersection C, the maximum possible values that it can take is 45. But here's a slight catch here. There is one more relation I know, which is M intersection P intersection C is actually a subset of M intersection P, P intersection C, M intersection C, meaning the number of elements in M intersection P intersection C would be lesser or at the most equal to the quantities in these sets, number of elements in these sets each 30, 50. So M is gonna be less than or equal to minimum of the three quantities, which is 30, 50, and 40. So what it tells me is number of elements in M intersection P intersection C is gonna be less than equal to 30. And so what I have is n equal to 30 as the maximum possible value that M intersection P intersection C can take. So you try to find this quantity also and then this one, and then you choose which one could have given you the answer. So it's a must case for you. Intersection of MP and C, number of elements in it has to be less than the number of elements in all these three sets. So amongst them, the minimum quantity is 30. So the possible values of n would be 30 only. And then that gives me M intersection n is equal to 15 plus 30. Small m was 15. small n is 30, the final answer that we get is 45. So I've tried to use the fact that for the maximum possible elements here, you take the minimum possible here. For the minimum possible here, you take the maximum possible here. Although in the case of this one, we found 45, but then I have to be wary of these relations also. So 45 could have been the answer had this 45 been lesser than the number here, but then 30 is the lesser number. So n has to be 30. There is no other way. And then m plus n becomes 45. There's a similar question I've taken up related to this one. It's just like this one. Okay, so here it is. A group of 40 students appeared in an examination of three subjects: maths, physics, and chemistry. Then again, something similar is given. So it's said that it was found that all the students passed in at least one of the subjects. So union is given to you here. Number of elements in M union P union C. M, P, and C I'm using to denote the maths, physics, and chemistry. So number of elements in M union P union C is 40. And then the other information I'll write. Number of people who study maths only, maths is 20. Number of people who study physics is 25. Number of people who study chemistry is 16. At most 11 people study maths and physics. So that would be M intersection P less than equal to 11. At most 15 students study physics and chemistry. That would be N P intersection C less than equal to 15. At most 15 students study maths and chemistry. So 40 students is group. It is found that all the students passed in at least one of the subjects. That's this information. 20 study in maths, 25 physics, 16 chemistry. That's this. At most 15 passed in both. So 11, 15, and 15. So these are the quantities. Maximum number of students who passed in all the three subjects is what we are supposed to find. So it's similar to what we did in the last question. We are supposed to deal with the intersection of the three subjects X here. Let me call this A, M, this be M, and this be C. So X is what we are interested in. Let me use the relation again. Number of elements in M union P union C is equal to number of elements in M plus number of elements in P plus number of elements in C minus number of elements in MP, number of elements in MC, number of elements in P and C, and lastly number of elements in all three. So I'll put the quantities related to these sets here. M union P union C is already known, that is 40. NM is 20. NP is 25. NC is 16. This quantities we don't know yet. M intersection P, N intersection C, M intersection C, P intersection C, plus the last one, which we are supposed to find, M intersection P intersection C. So what I can do is simplify because we want to get M intersection P intersection C. I can write the thing, I can simplify this equation as number of elements in M intersection P, number of elements in P intersection C, elements in M intersection C would be equal to, there is this 61, 61 minus 40 plus number of elements in M intersection P intersection C. So this is what I have. This becomes 21, and this is number of elements in M intersection P intersection C. Just like in the last question, I had mentioned intersection of M, P and C is a subset of M intersection P, M intersection C, P intersection C. So the number of elements in M intersection P intersection C is gonna be less than equal to number of elements in M intersection P, number of elements in M intersection C, number of elements in P intersection C, which means I am supposed to have number of elements in M intersection P intersection C less than equal to 11. MP is less than equal to 11. P intersection C is less than equal to 15. Number of elements in M intersection C is less than equal to 15. So the number of elements in the intersection of the three sets is also going to be less than equal to 11. So let's try this thing then. What I have got is M number of elements in M intersection P intersection C is 11. So if the value of number of elements in M intersection P intersection C, if it was equal to 11, I'm looking for maximum possible value of M intersection P intersection C. So had it been equal to 11, let's consider this relation. If the value of the intersection of the three is 11, then this relation becomes 21 plus 11, which would be 32. But if I go back here, number of elements in M intersection P is less than equal to 11. Number of elements in P intersection C. Okay, so this is one relation I'm getting. And we have this relation also, that number of elements in M intersection P is greater than equal to number of elements in M intersection P intersection C. So I'll use this thing. If I'm taking number of elements in M intersection P intersection C equal to 11, it would give me this relation, because I'm using 1 and putting the value 11 here, 32. But I have this relation also with me. So if this quantity were becoming 11, I would be having these relations, which also tells me that number of elements in M intersection P plus number of elements in M intersection C plus number of elements in P intersection C would have been greater than 11, greater than or equal to 11 plus 11 plus 11, and that's 33, contradicting what I have in 2. In 2, I have sum of the 3 equal to 32, but in this relation, I am being told the sum of these 3 is supposed to be greater than equal to 33. So 10 won't work for us. Let's go to the next best possible value. The next best for us would be number of elements in this is not possible. So the next best value that we can take is 10. 10 could have been the maximum. If I take the 10, I have, going back to the relation 1, so 1 gives me number of elements in the sum of the 3, M intersection P, M intersection C, P intersection C, that would be equal to 21 plus 10, 31. Again, I'll check for this relation. If the intersection has 10, that means number of elements in M intersection P, P intersection C, M intersection C. All these three are supposed to have quantity greater than equal to 10 number of elements in them, which means the sum should be greater than equal to 30. Number of elements in M intersection P, PC and MC. So this is what I have. So it doesn't contradict what I have here. This relation says the sum should be greater than equal to 30, which is true for us here. That's what is giving me the answer here. The maximum possible value of M intersection P intersection C, which satisfies the condition given to us in the question, would be 10 here. So two things are happening here. One is I had this relation. So whatever value of M intersection P intersection C you are taking is supposed to be consistent with this relation. When I took D11, I saw that the sum is 32, but then this relation was contradicting what I got here. This relation was giving me that number of elements in M intersection P is supposed to be greater than or equal to 11. So is the case with the other two. But then when you sum these three up, you get 33. That would mean the sum is greater than or equal to 33, contradicting what I have here. So we moved on to the next best possible number I could have taken, which is 10. When we took 10, the sum was 31, and the sum here, due to the inequality, was supposed to be greater than or equal to 30, which is consistent with what I have here. So the maximum possible value we can possibly take for M intersection P intersection C is 10. This question, it's slightly easier than the last one. For a class of 250 students, just like the last question, there are bounds on number of this mod M denotes number of people in M, mod P number of people in the set P, which is those people who are reading physics, same number of people who are reading chemistry, study chemistry is greater than equal to 80, less than equal to 90. Number of elements in M intersection P is 40, number of elements in P intersection C is 35, number of elements in M intersection C is 45. There are 50 students who study none of the three subjects. Find the number of students who study exactly one subject. So I would suggest you take a stop, try to do this question yourself, see whether you can crack it. So I'll start solving here. I have been given 15 students who study none of the three subjects. So let me find the union first. Number of elements in M union P union C would be number of elements in the universal set minus number of elements in none of the three. Number of people who study none of the three subjects. Number of elements in the union is 250. Okay, wait. Number of elements in the universal set is 250. And then number of elements in none of the three subjects, that would be 15. So this quantity is going to be 235. Now let's look at the question what it asks us. It says find the number of students who study exactly one subject. On the Venn diagram, how does the exactly one subject look like? So M here, let's say, assume P is here, and then C here. Exactly one subject. So if you're taking M, it would be the region of M alone, nothing else. So it's this portion they're talking about, the portion for number of students who study M alone. Same thing for P and C. Number of people who study physics alone would be here, and the number of people who study chemistry would be here. So it is this portion here. Number of people who are studying physics is this portion here, and number of people who are studying maths is this portion here. Now let's see what to do. I've already found out what number of elements in M union P union C is, and that is equal to 235. I am supposed to find the number of people corresponding to some of these three. So let's see what to do. Union relation is known to us, so I'll use the union relation. Number of elements in M union P union C is equal to number of elements in M plus number of elements in P, this relation. So this is the relation we have for the union. Now union is known to us. It has 235 elements in it. And the other quantities, we'll see what is given to us. Number of elements in M plus number of elements in P plus number of elements in C. These quantities are not known yet. M intersection P, M intersection C, P intersection C, these three are given. They are 40, 35, 35, 40, 45, 35. That would be 80 plus 40, 120. And then the intersection of the three, which is not known either. So this is what we have: N, M intersection P intersection C. Meaning number of elements in M intersection P intersection C is gonna be same as 235 plus 120, that would be 355, minus number of elements in M plus number of elements in P plus number of elements in C. We have been given that quantities in these three sets, M, P, and C, the maximum possible for them is 130, 100, and 90. Minimum possible is 120, 90, and 80. So when I use that, let me call this quantity as X here. So which means once when I take the maximum here, this would be minimum. When I take the minimum here, this would be maximum. So once when I take the maximum of M, P, and C, it would be 230 plus 90, that would be 320. 355 minus 320. So this tells me X, minimum possible value of X would be greater than equal to 355 minus 320. That would be 35 for us. X has to be greater than equal to 35. And when I use these lower bounds, M, P, and C has 120, 90, and 80 here. When I use these, I will have 210 plus 80, that would be 290. These are the minimum possible. So the maximum possible value of X can be 210 is there. So 355 minus 210. Wait, that's 310. So that would be 45. 120 plus 90 plus 80. Okay, it's 290. So we have 65 here. So X is supposed to be greater than equal to 35, but less than equal to 65. But then again, the things that we have been dealing with in the last two problems were M intersection P intersection C is a subset of M intersection P, P intersection C, M intersection C. So you have to be wary of this relation. And the quantity that it gives me is x is supposed to be less than the minimum of elements in the three sets. Minimum of 40, 35, and 45. Minimum is 35, which tells me x has to be less than equal to 35. So the two relations are giving me one, x has to be greater than equal to 35, less than equal to 65. Second, x has to be less than equal to 35 at the same time. What I have basically is x is greater than equal to 35 and at the same time less than equal to 35, meaning it is equal to 35. So we have found the intersection here. Now we were supposed to find number of people who study exactly one subject. So the shaded portion basically. What I can do is from the union of them, I can subtract this portion, this portion, this portion, and this portion. Let me call them as A here, B here, and the C here. So what I'm looking for, which is number of people who study exactly one subject, would be equal to number of elements in the union, which is 235 as we saw earlier. From it, I'll subtract number of people in the regions A, B, C, and X. X we have already found, X is 35. Let's find the A, B, and C here. For the B, B is the number of elements in M intersection P minus X. Intersection of M and P has 40 elements. 40 minus 35, that would be 15 for us. So the value of B is 15. Then the value of C would be number of elements in P intersection C minus X. Then again, 35 minus 35 is supposed to be 0. And then A would be number of elements in M intersection C minus X. Then again, that would be M intersection C, 45 minus 35, which gives me 10. 15, 0, and 10 is what I have. So it would be 235 minus 15, 0, and 10 is what we were having, plus 35. So what we have is 235 minus 15, 10, and 35. That would be 60 here. So it comes out to be 175. Let's check the calculations once. X has 35 elements in it. So M intersection P had 40. So this is gonna be 5. So it's 5, 0, and 10. It gives me a 50 here, and this is gonna be a 185 here. So that's the answer we are having. Number of people who study exactly one subject is 185. So what we did is we identified the number of elements in the union first. Then we were supposed to find number of people who study exactly one subject. So I marked the region, and then I went about seeing what could be done with the X that I have here. Using this relation, I got one bound on X. X is supposed to be greater than equal to 35, less than equal to 65. These 35 and 65 are coming out of the bounds here. But then I also knew one relation, which was number of elements in M intersection P intersection C is supposed to be less than equal to number of elements in the intersection of MP, PC, and MC, which gave me X is less than equal to 35. I combined these two inequalities, which gave me X is equal to 35. And then I just found the B, C, and A. and then summed it up, which gave me the value 185.